The third example we have here is about 3-methyl-hexane. Now let us look at it. Let us start numbering. The methyl group must be numbered from the smallest carbon ever. So instead of numbering 1, 2, 3, 4, 5, and 6, that will make 5-methyl-hexane. But no, we should always start our substituent from the smallest number ever. So let us follow the red color numbering. 1, 2, 3, 4, 5, and 6. So this should be a 2-methyl-hexane, not 5-methyl-hexane. Let us look at step number 4. If more than one branch of the same kind is present, use a di, a tri, a tetra, etc. to show how many similar branches are present. For example, in this example A, we have a 3,3-dichloropentane. How do we derive the naming? Let us look at the parent. The parent is an alkane group, so it is a pentane consisting of 5 carbon. And the 2-chlorine falls on the 3rd carbon, and there is 2 chlorine, so dichloro. And they both at the 3rd carbon, hence is 3,3-dichloropentane. Let us look at example B. Example B shows the 2,3,4-tribromopentane. It is the same number of carbon we have on the alkane group. The bromine falls on the 2nd and 3rd and 4th position. And there is 3 bromine, hence is 2,3,4-tribromopentane. Let us look at step number 5. If more than different substituents are present, they are named in the alphabetical order. For example, if bromine and chlorine are present, you will name the bromo first before the chloro. Hence, for this example, we will have 1, 2, 3, 4, 5, a 2,2-dibromo-4-chloropentane. Let us look at example or part B, where we have 1, 2, 3, 4, 5, 6, 7, 8. 8 carbon, hence an octane. However, we will have to start naming the substituent in alphabetical order, and the one that is of a higher alphabetical order should be named with a smaller number. So instead of the current numbering of 1 to 8, we should do the other direction. 1, 2, 3, 4, 5, 6, 7, 8. Hence, the octane will be at the 2nd carbon, and the bromo will be at the 2nd carbon, and the octane will be at the methyl will be at the 5th carbon. Hence, it's a 2-bromo-5-methyl octane. Multiplier like di, tri, tetra, etc., they are not considered when determining the alphabetical order. The commas is used between numbers, and the hyphens are used between numbers and words. This is very important and will sometimes be missed out by students. If the structures can be deduced from the name without the numbers is omitted. So we'll have bromo, ethane, because it is obvious that the bromo is at the 1st carbon. We can have propanol, and it will have a butanol for this case because the 1st double bond is at the 2nd carbon. Now let's take a look at the next one on naming cyclic and aromatic compounds. Cyclic alkanes are hydrocarbons which consist ring structures formed by carbon atoms bonded to other carbon atoms by a single bond. For example, we have a cyclopentane in this case. We could have a cyclobutane that looks like this. See, See, in a squarish shape. Hence, usually we have represented it to be a square, like this. In a cyclic compound, the hydrogen is often drawn at the carbons are also often drawn as a skeletal structure and not including the hydrogens. Let us look at the cyclic alkenes. Cycloalkenes are hydrogen carbons which consist of ring structures formed by carbon atom bonded to other carbon atoms by double bond. So for example, there's a double bond here. It is a cyclopentene. What about aromatic compounds? Soon there will be a chapter on arenes where you have to learn about the reactions of benzene rings. This contains the benzene ring where the electrons are delocalized inside the ring. More information will be discussed in later chapters. So you have a chlorine replacement of a hydrogen with chlorine group. It is known as a chlorobenzene. And if we have an alkyl group replacing the one of the hydrogen, it became a methylbenzene. Now, try exercise 1 about writing the structures from the following IUPAC name. The lecturers will follow up with this example before you begin the next lecture. Thank you and have a nice holiday.